Welcome back to the Chem OG. Today's lesson is about electrochemistry, which is a confusing topic for a lot of students. And so today's lesson is going to be very strategic and very to the point regarding things that are always going to be true when it comes to electrochemistry. And that way, if you know these things, you're always able to point yourself in the right direction. And so we're going to start by talking about some electrochemistry truths. These things are always true regardless of the situation. So the first true thing, or the first truth, is that electron flow is always anode to cathode. Doesn't really matter if the reaction is spontaneous or non-spontaneous. Electrons are always going to flow from the anode to the cathode. If you have a salt bridge in your electrochemical setup, and a lot of times you do, if you have a salt bridge, anions are going to flow towards the anode. In fact, that's why the anode is called the anode. Anode is a word that's made up of electrode and anions. So anions always go to the anode, and as you may have guessed, cations always go to the cathode. So regardless of the situation, spontaneous, non-spontaneous, anions always go to the anode, and the cations from the salt bridge always go to the cathode. The third thing that's always true is that oxidation always happens at the anode and that reduction always happens at the cathode. So these set of truths are always in vogue. Every single time these things happen, regardless of whether the cell is spontaneous or non-spontaneous. And so there's a lot of stuff that's related to what's happening on each side of the electrochemical cell, what's happening at the anode and what's happening at the cathode. And a good way to remember all of the things all at once, or at least if you take a look at a word you can recognize where that action is happening, is to take a look at the following. Vowels are going to be grouped together. So when I talk about the anode, the word anode starts with an A. So everything related to the anode is going to have a vowel in it. Check this out. Oxidation always happens there, as we just said. Oxidation starts with an O. O is a vowel. Anions on the salt bridge move there, right? So, and that's something that we just said. Electrons are going to move away from the anode, also something that we said. But what we're doing is we're tying all these things together in sort of a way that'll help us remember which one's happening where. One of the processes that happens at the anode is something called pitting. And that's because electrons are moving away from the anode. So a lot of times what we will observe is that metals, when they do lose those electrons, they're going to become cations. And those cations are going to float around in solution and they're no longer part of the solid. So pitting happens at the anode, is another thing that you should keep in mind. Now, consonants are going to go together. And so the other side of the electrochemical cell is the cathode. And so what's going on at the cathode? Reduction happens there instead. Cations in the salt bridge are going to move here. Electrons are going to move towards here. And plating happens at the cathode. So you notice that all these different letters in green are all consonants. And on the previous slide, everything was a vowel. So vowels together, consonants together is a good way of remembering what's going on at the anode and what's going on at the cathode. Now, a good thing to also bring up is what is the sign of the anode and the cathode? And so to take a look at that, let's remind ourselves that electron flow is always happening from anode to cathode. And we have two different types of cells that we're going to take a look at. There are spontaneous cells and there are non-spontaneous cells. And so if electron flow is always anode to cathode, as you know, electrons are negatively charged. And so if the electrons have to go to the cathode, regardless of the situation, then the cathode, if the electrons are going to move there on their own in a spontaneous reaction, the cathode needs to have a positive charge in order for electrons to go there willingly. And that means that the anode is going to have the opposite polarity. So the anode is negative and the cathode is positive in a spontaneous cell. And once you know that, in a non-spontaneous cell, everything's flipped. Okay, so that's a good way to know what's happening in a spontaneous electrochemical cell and what's happening in a non-spontaneous electrochemical cell. Think of where the electrons will head spontaneously. They're always going to go to the positive end, and that means that the cathode is the thing that's positively charged in a spontaneous cell. Once you have that down, you can fill in the rest of this table exactly the way that we did. It means that the anode's negative, and it means in a non-spontaneous cell, that the signs of the anode and the cathode are flipped. So that's pretty much the only difference between a spontaneous cell and a non-spontaneous cell, is the sign of the anode and the cathode. They're flipped in each of those scenarios. And so a spontaneous cell, as you know from nomenclature, is known as a galvanic cell. Sometimes they're known as voltaic cells. And non-spontaneous electrochemical cells are electrolytic instead. So that's a very, very brief summary of what goes on in electrochemistry, and hopefully that'll help you out in terms of being able to identify really quickly, what's happening where. So everything at the anode has a bunch of vowels in it, and everything at the cathode has a bunch of consonants in it.